Hello, welcome back to our channel. Today we are going to discuss about day 2 program. This is the second part and last part of the units and measurements. In this class completely we are discussing about what are the errors. The uncertainty in the measurement is called the errors. There are three types of errors are there: systematic errors, random errors and gross errors. What is the meaning for systematic error? In that only it's there. It is always either positive direction or negative direction. It is following one direction, unidirection, that is called the systematic error. Suppose we are doing the screw gauge experiment. In that that error is +4. So always the error is the +4 and correction is the -4. Any vernier calipers we are taking. So in that error is one digit. Whenever we are using that one, error is 1. So suppose you are having 1 meter scale, always it is showing the 1 centimeter error. So whenever you are using that meter scale, you are measuring the length of any object, always it is showing the 1 centimeter error. This type of errors are called the systematic errors. Due to the imperfection in the instrument, if you are not following the procedure and we are not following the technique and any instrumental problem, all belongs to systematic errors. But how to eliminate these systematic errors? We have to improve the experiment technique. Suppose meter scale is there. What is the error in that? 1 millimeter is the 1 centimeter is the error. Like that, when you are going through the vernier calipers, 0.01 centimeters, which is accurate. Vernier calipers is the more accurate. Then when you are using the screw gauge, that least count or error is the 0.01 millimeters. So when you are taking meter scale, screw gauge and vernier calipers, which is more accurate or which is more sensitive? Screw gauge is the more sensitive. Like that, when we are increasing the experiment technique, easily we can eliminate the systematic errors. Then our second error is the random errors. These are the unexpected errors due to the weather conditions, like when we are doing the current experiments like Ohm's law, meter bridge, tangent law, junction diode. Suddenly voltage fluctuations are coming. In our home, that electronic devices will damage. So generally we are facing this type of problems. We don't know the reason. That type of errors are called what? That is the random errors. Then third one is the gross errors due to the person. Suppose you are doing one experiment, your friend is disturbing continuously. That is due to your problem. So because of that reason, that recklessness, and we are not taking the care of that experiment, and we are not following the procedure. So because of our mistake, those type of errors are called the gross errors. But while doing the experiment, we have to find out the errors. First one is the true or mean value. True or mean value. These are the important. This is nothing but average also. Suppose A1 is the diameter of this marker. A1 is the diameter of the marker here. And A2 is the here. And A3 is the here. So we are repeating this experiment. How many number of times? N number of times. Same experiment we are repeating observations number of times. Like A1 is the first reading. A2 is the second reading. Like that, AN is the nth reading. Then how to find out the true or mean? See, A mean equals to sum of the quantities. Very, very important. Sum of the quantities by number of quantities. Sum of the quantities by number of quantities. We can write it A1 plus A2 plus and so on AN divided by N. Like that we can find out the A mean. If we want to do one example also, we are doing. Suppose A1 equals to 4 centimeters. A2 equals to 4.2 centimeters. A3 equals to 3.8 centimeters. Find the true value of this one. How to do this one? Take the sum of the quantities by number of quantities. So 4 plus 4.2 plus 3.8 is the 8. 8 plus 4 is the 12. Number of the quantities are 3. So true value is the 4 centimeters. Like that, in terms of decimals also they are giving. Whatever that the formula is, sum of the quantities by number of quantities is giving the mean or true value. Then our next one is the absolute error. Absolute error means we have to we have to eliminate the error. For that we have to follow the techniques. First preference is the mean. Absolute error means what is individually we have to find out what is the error in A1, what is error in A2, what is the absolute error in A3. Suppose absolute error in A1, we are taking that formula is A mean minus A1. A mean minus A1. Already you know that A mean is how much? 4. A1 is how much? 4. So here absolute error is the 0. Like that absolute error in A2. A mean minus A2. Why we are taking mod? Always we are getting the positive only. See, this is also 4 minus 4.2. 0.2 is the absolute error in A2. Like that A3 is the A mean minus A3. We can get it here 4 minus 3.8, that is 0.2. So like that, suppose n number of readings are there. Delta an equals to A mean minus an. Like that individually we can find out the mean absolute error in A1, absolute error in A2, absolute error in A3. Like that we can able to find out the absolute error. So A mean is over, absolute error is over. Then we can go through the mean absolute error. How to find out the mean absolute error? Sum of the absolute errors by number of quantities. That is the mean absolute error. Look here. Mean absolute error equals to delta A1 plus delta A2 plus and so on delta AN divided by number of quantities, how many are there? N. Just now we discussed one example. See, delta A1 is how much? 0. Delta A is how much? 0.2. Delta A3 also 0.2. How much it is? 3. So 0.4 by 3. It should be right 0.133 like that. So this is the mean absolute error. Practically we can find out. Then our next one is the relative error. Relative error. What is the relative error? Mean absolute error by A mean is called what? Relative error. Just now we know that delta A mean is how much? 0.133, and that is the 4. When we are doing the simplification, 0.433, this is the relative error. When we know the relative error, we can able to find out the percentage error also. How to find out the percentage error? That formula is very simple. Relative error into 100. That is called the percentage error. That is called the percentage error. So these are the different types of errors while doing the measurements. Next topic is the combination of errors. We can observe the errors in addition, multiplication, subtraction and division. In the case of addition and subtraction, look here. A plus or minus delta A is there. And this is, and B plus or minus delta B is there. So this is the physical quantity and this is the error. This is the error in B. We want to add these two. So how you will find out the error? Error plus C. We are taking C equals to A plus B. Then how to write the error in addition? C plus or minus delta C equals to A plus or minus delta A plus B plus or minus delta B. So C plus or minus delta C is the A plus B plus or minus delta A plus or minus delta B. So we can find out here maximum possible error. Here we can find out the maximum possible error. So maximum possible error is the delta A plus delta B. Minimum possible error we don't want, just maximum error only we have to find out, then only it is useful. Suppose practically we are taking A plus or minus delta A is the 2 plus or minus 0.1 and B equals to 1 plus or minus, otherwise we are taking this is the 4 and this is the 1 plus or minus 0.2. Then how to find out the error in addition? C plus or minus delta C. As usual, we should add A and B value. 4 plus 1, 5. And maximum possible error is 0.1 plus 0.2 is the 0.3. So in addition, error is 0.3. Like that, another side we are taking the error in subtraction. This is the error in addition. This is the error in addition. The next thing is the error in subtraction. Same here also. We are doing like A minus B. C plus or minus delta C. We are taking A minus B. So instead of A, we are taking 4. 4 minus 1 is how much? 3. Then plus or minus. For subtraction also we have to take the maximum possible error. So many people are doing mistake. We are subtracting these two means these two also they are doing. No. In addition and subtraction, both the cases we have to take the maximum possible error. So here is how much? Once again we are getting 0.3. One more example we are doing. X plus or minus delta x is the 5 plus or minus 0.02. Then y plus or minus delta x is the 3 plus or minus 0.01. So find addition and subtraction including the error. So x plus y, what we are writing? 5 plus 3 how much? 8. Error is how much? We should add 0.03. And subtraction also, what we are taking? 5 minus 3 is the 2, and error is as usual same because this is the maximum possible error. In addition and subtraction, we have to take the maximum possible error. Then our next method is the error in multiplication and division. Error in multiplication and division. Look here. In both the cases, we are getting the same formulas. Suppose if x equals to yz, delta y is the error in y, delta z is the error in z. If x equals to yz, how to find out the error in x? We can write it. Error in x equals to delta x by x equals to delta y by y plus delta z by z. This is for both multiplication and division. Even y by z also you can get it. Delta y by y plus delta z by z. How to do this one? One practical example we are taking. Look here. Here if x equals to, y equals to 4 plus or minus 0.1 and z equals to 2 plus or minus 0.1. Okay. Find error in xy and x by y. Both are same only here. So error in xy and x by y we are taking. Error in xy or x by y, delta x by x plus delta y by y. Here delta x is how much? 4 by, this is the x value, this is the yz we are taking. Delta y by y plus delta z by z. So here this is delta y is 0.3. 0.3 by 4 plus 0.1 by 2. 0.1 by 2. So carefully you should observe that error in y is 0.3. And we have to find out the error in multiplication and division. So this is the formula for that. Like that powers are there. If x equals to y power a, z power b. Find error. Find the error in x. How to find out? Same, delta x by x equals to, power is coming as a multiple, a into delta y by y, a times of this one plus b into delta z by z. Like that. Suppose we are, one more example we are taking. X equals to y power a by z power b. This is the division. Here also error in x is delta x by x equals to what we are getting? Delta x by x equals to a into delta y by y. Same you are getting b into delta z by z. So this is the error in multiplication and division same. If powers are there, we are getting powers as a multiple, then we can find out the error in this. Few examples we are discussing how to find out the errors. Look. What is the formula for time period? Time period is depends on the, already we know that the relation between different physical quantities. Time period is directly proportional to under root L by G. Find error in T is how much? Delta T by T. This is L by G whole to the power of 1 by 2. So it should be right, delta T by T equals to 1 by 2 into delta L by L. If you want to write one more step, L to the power of 1 by 2, G to the power of 1 by 2 plus 1 by 2 into delta G by G. So this is the error in time period. Suppose they are giving error in length is 2%, delta L by L is the 2%, and delta G by G is the 4%. Then how to find out the error in time period? 1 by 2 into delta L by L we are taking 2%, and delta G by G we are taking 4%. After simplification we are getting how much? 3%. 1 plus 2, 3%. Not only this one, what is the kinetic energy formula? Ke equals to half mv square. They are giving error in mass is 3% and error in velocity is 1%. Find the error in kinetic energy means delta Ke by Ke equals to, see, we should write it, power is how much? 1. Don't take this constant, we are not applying the units and measurements to the constant. So delta m by m plus 2 into delta v by v. You know that instead of delta m what we are taking? 3% plus 2 into 1%. After simplification our answer is how much? 5%. So like that we can calculate the error in multiplication, addition, subtraction, division and powers also it's there. And one more problem we are going to discuss. Look here. Error, suppose the problem is like this. Error in radius of the sphere is 2%. Find the error in volume. Find the error in volume. See, sphere, what is the formula? Volume 4/3 pi r cube. 4/3 is constant, pi is constant. What is the relation between them? V is directly proportional to r cube. So delta V by V equals to 3 into delta R by R. So instead of delta R by R, what we are writing? 2%. So 3 2s are how much? 6%. This is the error in volume. Like that we can calculate. Now I said power is coming as a multiple and we can find out the errors. But it is only useful up to 5%. Suppose error in mass is 2%, error in velocity is 5%. Up to 5% only we can use. If the error is more than 5%, look here. We know that time period equals to, otherwise time period is directly proportional to under root L by G. Generally what we are taking? Delta T by T equals to 1 by 2 into delta L by L plus 1 by 2 into delta G by G. This is we can use up to 5% only we can substitute. Suppose if length is, if L2 is like 6% more than L1. At that time we can't use, find the G is the constant. Here G is constant. Then how to find out the error in time period? Look here. Delta T by T. Otherwise first we can go through the relation between them. We should write it T1 by T2 equals to under root L1 by L2. L2 is how much? 6% more than that L1 means 6 by 100 times of that. L2 equals to 6 by 100 times of that L1. So we are taking L1. So L1, L1 cancel. T1 by T2 equals to how much? 100 by 6. After doing this, how to find out the error in time period? T2 by T1 we are writing 6 by 100. Then both the sides we are taking the minus 1. 6 by 100 minus 1. Just I am giving the example. T2 minus T1 by T1 equals to 6 minus 100 by 100. Then you can get it. T2 minus T1 by T, we are taking delta T by T equals to 6 minus 100 is how much? 94 by 100. In terms of percentage, delta T by T, we are multiplying with 100. So our answer is how much? 94%. Like that, if it is more than 5%, we must follow this method to find out the errors. Then our very important concept next thing is what are the significant figures and what are the rules to do the arithmetic operators. What are the significant figures? See, the reliable plus first two uncertain digits or first one uncertain digit is called the significant figures. Suppose your height is 5.3234 like that. See, 5.32341456 like this. It's very difficult. So here, what are the reliable digits? This one is the reliable. Plus one uncertain digit. So we can take it 5.32 feet. This is called the significant figures, and this is the importance for the significant figure. Then what are the rules for significant figures? Look. What are the rules? All non-zero digits are significant figures. Like example, 5, 2, 6, 7. How many number of significant figures? 1, 2, 3, 4, 5. All are the non-zero digits. So these are the significant figures. Then second rule is, if zeros are in between non-zero digits, like example, look here, 4623.01. So how many significant figures? See, these zeros are also we should calculate. Why? These are coming in between the non-zero digits. So 1, 2, 3, 4, 5, 6, 7, 8. 8 are the significant figures. So first rule is the all non-zero digits are the significant figures. Second rule is the if zeros are coming in between the non-zero digits. One more example, 1.002. What are the significant figures? 1, 2, 3, 4. 4 are the significant figures. Then third rule, if the number is less than 1, like 0.00123. How many significant figures? See, right of this decimal and before this non-zero digits, we won't consider these are the significant figures. Like, so these 1, 2, 3, these are the significant figures. And one more example, 0.02305. So here also we should consider this 0. Why? It is in between non-zero digits. We should omit these two. So our significant figures are how much? 4. These are the significant figures. Then our next rule is, look here, if the number is greater than 1, 3600 is there. After non-zero digit, if there is no decimal, see, look here, we are taking 36.00. See, these are the decimal is there, before that non-zero digits and after that zeros are there. But here you should consider all are the significant figures, and that too the number is greater than 1. So here 4 significant figures are how much? 4. Like that, 50, 584.00. What are the significant figures? 1, 2, 3, 4, 5. Like that we should calculate. And one more example, look here, 3600 I am writing. Here generally what do you say? You can say 1, 2, 3, 4. It's not right. Always you can take it. If there is no decimal, only non-zero digits, 36 is the significant figures. This number significant figure is how much? 2. So all non-zero digits are the significant and zeros are in between non-zero digits are the significant. If the number is less than after the decimal and before the non-zero digit, we should omit that one. If decimal is there, after decimal zeros are coming, and here 36.00, here the significant figures are 4. Like this number is a, we won't consider these two significant, these two are the significant, here 2 is the significant. Then one more very important, what are the rules to do the arithmetic operations? Before that, just to remember that while doing the addition, subtraction, multiplication, division, we have to suppose A1 equals to 1.23, A2 equals to 1.24, then A3 equals to 1.26, like that. After adding, this is 1.2 and this is 1.2602. After adding, what is the significant figure according to the rules? Look here. Here how many significant figures are there? 3 are there. Here how many significant figures are there? 2 are there. And here how many are there? 1, 2, 3, 4, 5. Look here. We should add that significant figures 3 to 5. But answer, no, some cases no, in exams, no need of doing any calculations and all this. Always, even addition, subtraction, multiplication, division, we should express in terms of least significant figures. Your answer is like this. After adding approximately how much? See, 1.23, 1.2, 1.2602. So after adding, our answer is, see, 3.6902. But it is wrong. According to significant figures, our answer is, it must be follow the least significant. Least significant figures is how much? 2. So our answer is how much? 3 point, after rounding of the numbers, we are getting 3.7. I tell you now only what are the rounding of the numbers. So we should express the answer in least significant figure while doing the calculations like addition, subtraction, multiplication and division. Then our last topic in this is rounding of the numbers. What are the rounding of the numbers? Look here. Here also some rules are there. Rounding of the numbers. We are taking one number 3.507. Here how many significant figures are there? 4 are there. Now we want to bring to this is to 2 significant figures. How to bring this one? We should omit these 2. Simply you are getting 3.5. Second rule, you look here. 3.567. Here also 5 significant figures. We want to bring to 2 significant figures. See, first one no change. Second one also 5 is there. But omitting digit is more than 5. That's why 1 digit you should add here. So our answer is how much? 3.6. Here 0 is there. It is less than 5. That's why we are not adding here. Here 6 is whatever we are omitting the digit more than 5. We should add 1 digit to this one. And one more example we are taking. 3.7862. How to round up this number? We want to bring to 3 significant figures. Here already how many are there? 5 significant figures. See, I am writing 3.79. Because it is 6, no, it is more than 5. That's why we are adding 1 digit to this preceding digit. These are the rounding of the numbers. Not only this one, look here. If it is less than 5, no need of adding. If it is more than 5, we should add. Suppose if it is equals to 5. Look, we are taking few more examples. 3.556. How many significant figures are there? 4 significant figures are there. We want to bring to 3. 1, 2, otherwise 2. So we are getting generally 3 point. See, this 5 is the omit. It is equals to 5. It is not greater than 5. It is not equals to 5. Not less than 5. It is equals to 5. It is odd number. If the preceding digit is odd number, our answer is 3.6. Same number you look here. 3.5 3.456. But our answer is only 3.4. What is the difference? Preceding digit is odd, we should add to one digit. Preceding digit is 4, that is even, that's why we are not adding. These are the rounding of the numbers. Thank you everyone. Please subscribe my channel, and this is the day 1 and day 2 program of the units and measurements.